Okay, in the tutorial, I'm going to describe what an Esker is and explain how it's formed, and I'm also going to show you how you can draw a diagram, a two-stage diagram, to help explain the formation of this feature. Okay, so what I suggest you might want is a piece of paper and a pen for the second half of the video as I outline how this feature forms. So let's have a little look at the Esker. So first of all, the Esker is, unlike the terminal moraine, it's a feature that's created within the glacier, okay? And the first thing you have to understand about the way glaciers work is as they are moving, they are also melting. Especially because the surface of the glacier is in contact, that's up here where I'm indicating, in contact with the sun, and therefore the top of a glacier will actually be melting. And all of that water will automatically fall down to the base of the glacier and flow along the bottom of the glacier. Now, this is all hidden from human eye. It's happening underneath the glacier. But eventually it'll get to the front of the glacier where we can see this person standing, the snout of the glacier, and it will pour out. So what we can see in this image is an actual, a subglacial meltwater channel, which during the Ice Age would have been absolutely full of water. And as that water is all moving through the base of the glacier, it's also carrying with it all of the glacial material. Okay, the sands and the gravels that are being picked up from the valley floor as well as elsewhere in the landscape. And if we look here, we can actually see inside one of these glacial channels, we can see all this material. It's quite rounded because it's getting actually eroded through processes like attrition, which is where rocks collide with each other and break up. So over time, this material, because it's flowing in this subglacial river, it's actually behaving like any material in a normal river would do. And it's getting eroded down into nice, smooth, small stones. So at the front of the river, where it emerges from the glacier, you're likely to find quite rounded rocks. Also, the material in the Esker itself is sorted. So this material at the front is going to be quite small. And as we move further back up through this meltwater channel to the back of this subglacial channel, you'll get much bigger material because the heavier material, the heavier rocks are deposited first because the flowing river can't move them. Okay, this diagram kind of shows you what's going on. So here's the glacier itself, and we've kind of made it look invisible so we can actually see what's happening inside the glacier, and we can see this meltwater channel here, and this pit here would match this photograph, occurring underneath the glacier. And all this brown stuff is all the sands and gravels that are being transported by this water as it flows across the base. Now, as the glacier gets to warmer climates, as it travels out of the mountains into lower altitudes, it'll obviously start to melt, it'll get thinner, it'll lose its energy, and therefore it'll start dropping more material until eventually the glacier disappears completely, and we end up with this ridge, this narrow ridge of meandering glacial deposits, okay? And it's meandering just like a river meanders because underneath the glacier, it would have been doing exactly the same because it would have been behaving like a river behaves, and it meanders across the landscape. Here we can see actually the terminal moraine. So this is the end point that the glacier got to. Right, let's actually have a look at how we would draw diagrams to show this feature. Now I'm going to do this as a two-step diagram, like I did with the terminal moraine. So we're going to build in our valley floor. This is our U-shaped valley floor, okay? And I'm going to put my glacier onto it. And there's my glacier, okay? Now I'm going to add a different color to show my meltwater channel flowing along the base of my U-shaped valley and coming out the front. Okay. Let's just add some key labels. So if we're getting marked on this, we can actually show what all these things are. So this is a glacier. It's a cross-section of a glacier, actually. This is my glacier. This is my floor of my U-shaped valley. And here we have the meltwater channel that we want. Meltwater channel flowing at, I should say, underneath the glacier. Now, there's a huge amount of water moving here because obviously as the glacier scrapes across the U-shaped valley, there would be a lot of friction, so a lot of the ice would be melting at its base, which is why there's so much water flowing under. And it's actually this meltwater channel that lubricates the glacier and causes it to slip across the landscape. Okay, so that's just a few other key kind of bits of information that might help you understand what's going on here. So there's our meltwater channel right there. Okay, so it's going to build up an Esker, and we need to sort of start with what is an Esker. We'd want to just put a side annotation here. So Eskers form in meltwater channels or let's put meltwater streams beneath the glacier. So we're starting to build up the idea of what this feature is and where it's created. Okay. Now, what's this meltwater stream doing? Well, I'm going to add some additional information. I'm going to add some rocks, and I'm going to put some bigger kind of things to show my large rocks up here at the back. And I'm going to put smaller rocks down here. And then tiny little dots here. Okay, so I'm indicating that my meltwater channel is sorting material into large, smaller, and very small. Okay, as this river can't carry this stuff. So I need a little label that tells me this information. So let's just pop a little label on there. So large material is deposited further up channel as it is too large and heavy to be moved downstream. Okay, so we need to say the reverse for the small stuff. Smaller sand and gravel deposits travel downstream due to size. So what we now want to say is Esker, therefore, contains sorted glacial deposits. And they're sorted because they're getting sorted by size based on how far they move in this meltwater channel. Okay. One other key thing I mentioned a second ago is these actual glacial deposits, unlike in the thermal moraine, they're rounded and smoothed. Okay. So I want to say that glacial deposits in an Esker are rounded due to attritional, that's the process of attritional processes in the meltwater channel that erode them. In the meltwater channel that erode them. Okay. Bigger. So there we have our next deposit, our next bit of information. So we've got quite a lot of information now. Now what I want to do is I want to take this diagram a little bit further forward and just show you what's actually happening. I'm going to create a second diagram which has a retreating glacier. So I'm going to put my valley floor on again. This time I'm going to have my glacier having retreated because it's melting. Okay. So my glacier, I'm going to put a back arrow. Now, a glacier doesn't move backwards. It can't defy gravity. But I'm just putting in that to illustrate that my glacier is retreating. So glacier starts to melt and retreat in lower altitudes due to warmer temperatures. Okay, so that's my first label where I'm giving some information about what my glacier is doing. Now, as it retreats, it starts to drop its sediment. Okay, So I'm going to put some actually inside the glacier here, my big stuff. These are my bigger material that didn't move as far. And then as we move down, just indicating my smaller material. It's not that important at this stage. We're just trying to create our Esker on our valley floor. Okay. So let's put a little label in that tells us what's happening in this second step. So glacier is losing energy and therefore drops even more material in its subglacial tunnels. In the same way that if you were carrying heavy bags for a long period of time, you'd start to get tired, you'd start to lose energy, and as you lost energy, it's more like you would drop those bags. Well, the glacier can't hold on to material if it's losing energy and it starts to drop it. Okay, so we're almost ready to finish off our final description of what this actual feature is that's now starting to appear. We can't see it when the glacier is actually moving forward because it's underneath the glacier. But as the glacier starts to move back, the actual Esker itself is revealed, and our Esker is, if we just describe it, the Esker is now revealed on the floor of the U-shaped valley as a meandering, low-lying ridge. Okay, that is your Esker. Okay, and those labels will get you more than enough marks in an exam question on the Esker.